Okay, so we finished printing up the shapes for the geometry problem, and we found our old shapes from a geometry problem your brother did last week. And I actually want to start with you talking about this problem. Do you know how to build this up into the big square?
Yep.
Yeah.
This, you can create a bunch of these shapes. And then you put them on this. And you can form a square.
Cool.
Yep.
And so we have a big square around the outside and a little square on the inside.
Yep.
And the problem asked, what is the ratio of the area of this square to the big square? And how do we solve that problem with our little shapes we printed?
We can put these on here, and then we can see that it forms 4 other squares that are identical to this one. So the ratio to the big square to the small square is 5 to 1.
5 to 1. Pretty cool, right?
Yep.
Pretty cool. Now we're going to do a similar project with the shapes we just printed today. So here we have those little circle tops.
Yep.
And you can see the equilateral triangles on the inside. And the question was about finding the area of this shape. And you don't know about areas of equilateral triangles or circle tops, do you?
We could look at the pieces of the the areas of the equilateral triangles and the circle tops, and multiply them by 4 to get the entire area.
Okay, well, what do you mean? What shape are you making? Show me.
Well, what if you attach these together?
Do you know how to find the area of that shape?
Not really. It doesn't look like a circle.
It doesn't look like a circle, no.
Well, what if we maybe we can somehow attach these bits together.
Okay.
If they're circle tops, they might form a circle.
If they're circle tops, maybe they'll form a circle. Yeah, interesting.
So, like, if you put them together.
Does that look like a circle, or does?
Sort of.
Well, but what are you going to do with the equilateral triangles? Let me move these out of the way so we don't get mixed up. You have some pretty interesting ideas. They do seem to be circle tops.
Well, we have 4 of each shape, so we could find the area of this.
Ah, interesting. Okay. Why don't you make all 4?
But wait. What if we sort of... we're 2 slices short.
What does that mean?
Well, this is 4/6 of a circle.
Interesting, huh?
4/6 of a circle.
And that circle, I think it said the length of the equilateral triangles was 1. So what would be the area of the circle if the circle had radius 1? What would its area be?
Well, that would be pi.
Pi. So what's the area of our shape?
That would be the pi times the square root of 3.
Well, no. What's the radius of the circle, of our nearly completed circle here?
Well, it's 1 high.
It's 1.
So the radius is 1.
So the radius is 1. So if
So
we had a
it's
full
pi.
circle, it would be
It would be-
pi. But we don't quite have a full circle. What do we have?
We have 4. It would be 4/6 of pi.
4/6 of pi. Can that be simplified at all?
Well, you can do 2/3 of pi.
2/3 of pi. Isn't that interesting?
Yeah.
It's pretty neat, right?
Yeah.
And it helps you printing these shapes helps you see how you can rearrange those pieces into 2/3 of a circle.
Cool.
Pretty cool, right?
Yeah.
All right, good job, huh?